Hello guys, assalamu alaikum. Welcome back to my YouTube channel. So before we jump into deep learning, let me briefly define what machine learning is and what it is all about in a few minutes. So it all goes back to the traditional programming paradigm. And what do I mean by that? It's like the development of computer software to make our lives easier. So I think one of the motivations behind developing software was to make common tasks more convenient. For example, placing physical mail by, let's say, email. Although it's not 100% replaced, but yeah, with that like change, now things are a little bit more convenient compared to writing a letter by hand and then bringing it to the post office and then taking a few days until it's delivered and so forth. Email makes this whole communication aspect more convenient. Although I would say maybe email is not so great because everyone including me, uh, think that email is maybe not making life easier but harder because there's no more email than physical mail. In any case, so let's now imagine you have an email program and you want to make email more convenient. You want to filter out spam, so that is unwanted email. So imagine you want to design a spam filter. As a programmer, you want to design the spam filter. So our program is the spam filter, and then we can give this to the computer, would then produce the outputs, which would be the label whether something is spam or not spam, or maybe going one step further, just putting it into the right folder, like either the inbox or the spam box or our email program. On our email program, now how do we design this filter? I mean, as a programmer, this could be a very tedious exercise. We would first take a look at examples of email. So we would take a look at our inbox and then look at what could be some spam email. We would then compare it to non-spam email. Just think about it and maybe come up with a rule that says, for example, if let's say if email has the word let's say win money or something like that in the subject, then classify it as spam. And then you can have an else, if else something like that, and so forth. You can develop these rules, hard code them in your program, and then develop a spam folder like that. But I think it would be a super tedious to do that because you would have to take a lot of messages and do a lot of testing and see if your rule works. And it is like a lot of work, like to take a look at this. And this is why machine learning is so popular, because it can make this life easier for us programmers for developing software that can, for example, classify things. So here, in contrast, at the bottom, I have machine learning in contrast to the traditional programming paradigm. So in machine learning, instead of having the programmer look at these inputs and making decisions, we provide the machine learning algorithm with inputs and outputs. Again, outputs would be the labels for our email. So we have a labeled data set. So here, this would be our emails, and the outputs would be whether they are spam or not spam. So a human actually would have to label those. So you have to have a human to assign these labels to show the computer what we want. So it's basically, this is what we want to, the desirable outcome. So we have, as a human, we have to of course communicate to the computer what we want. We have to say, okay, we want spam and non-spam email labels. So we provide these as examples, and then the computer can learn rules to make these classifications. So the computer is actually developing this program. This is our machine learning model, and then the machine learning model can actually replace our role as programmer. Developing the program manually, we can actually give the program directly to the computer to produce new outputs on the new data. So machine learning is in a way the automatic learning from examples. So there is also a famous quote by Arthur Samuel. This is a code that you can find in almost every machine learning textbook. So the code goes like this: Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So here, that means we are providing examples, and then the algorithm learns automatically from basic from the based on the data instead of having humans thinking about these rules. That's machine learning in a nutshell. So specifically, this is a subfield of machine learning called supervised learning, which I will talk about in the future videos. So yeah, but you may wonder how this machine learning now related to deep learning and, for example, artificial intelligence. You probably all heard about AI and artificial intelligence. Most of the time nowadays, deep learning and AI are used interchangeably. However, there is a distinction I wanted to briefly discuss. So, machine learning, I would say, is the biggest field. Machine learning is the biggest field. It's like a field encompassing deep learning. So deep learning is strictly a subfield of machine learning, a subfield that focuses on neural networks, deep neural networks, and AI is intersecting with both. I would say if there is one thing about this graphic, is I made this one. Maybe I'm not. Not big enough, but maybe I made this part here too big. So there is also what I wanted to say here is that there are also AI methods that don't use machine learning. So let me go through these things step by step. So first of all, there are three different types of AI. Usually we say generally AI as artificial intelligence, which is a subfield of computer science, solving tasks humans are good at, for example, natural language, speech recognition, image recognition, and so forth. And then we can subcategorize AI into two smaller categories. One is narrow AI, and one is artificial general intelligence. So, what is narrow AI? Narrow AI is the form of AI that is focused on solving a particular task, so only one task at a time. For example, image classification, or playing a game, or driving a car. Let's say an algorithm for unlocking your phone. So this would be a narrow AI because it can only do one task. So it's not like a human. A human can do multiple things. I can go skiing, I can go cooking, I can write emails, I can record a lecture and things like that. So I can do multiple things, but narrow AI system can only do one thing that it has been developed for. In contrast, artificial general intelligence is multi-purpose AI, mimicking human intelligence across multiple tasks. So if you have seen the movie Ex Machina, the robot in this movie, for example, I would say it would be more like AGI agent, where it can do things a human can do. So multiple things, not only classifying images, for example. So in that way, there's a difference between narrow AI and AGI. However, AGI is for most people what they want to accomplish is like the far future goal, but we are not very close to that one yet. So that's like people are actually arguing whether it's possible at all, whether it will be possible. Some people think it's like within 50 years. Some people say within 1000 years. There's actually a nice book on what was the name, Architects of Intelligence, where the author, his first name is I think Ford. So the author interviewed multiple experts in deep learning when they would predict AGI will be invented. And there's like a huge span of prediction between 20 and 20 years, and maybe 10,000 years, or maybe never, or things like that. So no one really has a good idea even when or if this will ever be invented. Narrow AI is something that we have nowadays in almost every aspect of our lives, and I will also talk more examples of that. So AI, there were there was also something called a good old fashioned AI. It does not always have to involve machine learning. For example, when we developed our spam filter a few slides back, when I designed these if and else rules as a programmer, I was developing an intelligent system, right? If I add enough of these if and else rules, this system will be intelligent and will be able to sort my emails by spam and not spam. However, for that I didn't use machine learning. So in that way, AI doesn't always have to use machine learning. Nowadays, most of the AI systems use machine learning though, and also even more of them are using deep learning, because deep learning is usually very good at natural language and computer vision. So this is also the focus of this course, and this course will be focusing on deep learning. A regular machine learning that is not deep learning could be, for example, generalized linear models, for example linear logistic regression, tree based methods, certain methods like random forests or gradient boosting, support vector machines, k nearest neighbors. So these methods only because we call them traditional doesn't mean that they are bad. They are still really powerful and useful for tabular data. I will explain what I mean by that later. So they are really good at learning from tabular data, and deep learning is more suited for learning from raw data like images and speech and things like that. So it's not like one is better than the other. The purposes are kind of different. So that's the main difference basically. Yeah, so just one more example of an AI system that does not involve machine learning and deep learning. So as far as I know, Deep Blue, that was like old chess computer, is not based on machine learning. It is like using an alpha beta search, which is a search algorithm for finding good chess moves. And as far as I know, for example, this would be an example of a good old fashioned artificial intelligence that is not involving machine learning. I may be wrong, but then there are definite examples of AI systems that do not use machine learning. So, in general, we can say that AI is a system that employs rules and is kind of intelligent through these rules by using these rules. For example, if you think back of our spam filter that we could develop by hand by having a lot of if and else statements, this can become intelligent as a narrow AI, but it doesn't necessarily have to involve machine learning. And yeah, machine learning is about algorithms that learn models or representations or rules automatically from data and examples, like the labeled data. For example, if you think back of the slide that I showed you when we showed algorithm examples of labeled email, and then the algorithm would develop the program that would be what machine learning is about. And the deep learning is also machine learning, but it is specifically focused on multi-layer neural networks. So they are a little bit more and more complex than simpler algorithms that are not necessarily uh, they have usually more parameters, you can say, and we will see all about that in this course as well. So here are some applications of machine learning and deep learning in practice. One we have already covered, the email spam detection. Another popular example of machine learning would be deep learning specific that would be fingerprint and face detection and matching on the phone. So if you have a smartphone, you probably either have a fingerprint sensor or a camera that detects your face to unlock your phone. Or web search is also heavily using machine learning and deep learning. For example, DuckDuckGo, Bing, and Google Spots predictions. People use it for making predictions. At the post office, also machine learning and deep learning are used for scanning the letters, the letter sorry, the letters on the letters and the zip codes, and then categorize the letters by zip codes like image recognition and hand recognition. And the same is true for the ATMs for reading checks. This was actually one of the earliest applications of deep learning or machine learning. It was a multi-layer neural network, in particular convolutional neural network we call it, which we will be covering in this course. It wasn't called LeNet Mm, and it goes back to 90s, and that was one of the early applications of deep learning. I mean, I say deep learning, back then the term deep learning wasn't even invented. So back then people called it machine learning, but it was a deep neural network. So here's a fun video, you can see. Let me play it. It's a real video from the 90s illustrating how this works. So here's a handwritten image of the handwritten digit, and then the machine learning here, machine learning system here, recognition which digit that is, and that can be then used in the ATM, for example, or for sorting the zip codes. So of course we will be developing much more sophisticated systems in these next couple of weeks or next couple of lectures, but this is, I think, a nice example of classic deep learning. Now the other applications include, for example, smart assistants like Apple Siri, like the voice assistant, and also Amazon Alexa. And all these types of voice assistants nowadays are using deep learning. And then the product recommendations, if you know Netflix or Amazon, they always recommend products based on machine learning. Self-driving cars, unfortunately, still not here yet. I mean, I'm not sure if it's unfortunate, but that would be another great application, not application per se, but at least example of deep learning. It's actually a bit complicated, so there are many things at work, from reinforcement learning to supervised learning with images. So here's a little example from Waymo. Let me play the video. So that would be another area where AI, deep learning, machine learning are used. Mm, Language translation, sentiment analysis, drug design, medical diagnosis, and things like that. But yeah, that is just a quick overview of machine learning, just to lay the groundwork. And then in the next few videos, I will also say a little bit more about the subcategories of machine learning. It also applies, of course, to deep learning, because we have learned that deep learning is a subcategory of machine learning. And we will also talk more about workflow and some jargon, and then about the tools we'll be using in this course. So this is still all lecture 1, and then I will pause this video here and then record the next one on the broad categories of machine learning. So if you have any comments, or if you want to know more, you can comment on this section below. Until next video, I'll see you in the next video.